Hi, this is Mr. Manley. Here I want to talk about polynomial functions. Now, most likely you've worked with polynomial functions quite a bit already. You've worked with lines. A line is a polynomial function. You've worked with parabolas. A parabola is a polynomial function. Maybe you've even worked a little bit with a shape that looks like this. And that's a cubic function. And then finally, maybe you haven't seen this before. That's a quartic function. And we can go on and on with this. Now, each of these has an algebraic form, right? The line is based on x. The parabola is based upon x squared. The cubic is based upon x cubed. The quartic is based upon x to the fourth. And then for each of these, I could have the positive form of it, where it's rising from left to right or opening up, rising from left to right, opening up, or I could have the negative form of it, dropping from left to right, opening down, dropping from left to right, opening down. So each of these is a type of function, or is a different type of polynomial function. And just by knowing its degree and whether it's positive or negative, we have an idea about what it looks like. There's a way of referring to this for each of these. We talk about the left-right behavior. And we say, does it fall or does it rise? And are we on the same page with this, I wonder? For instance, if I look here, if I'm looking there, I'm saying that rises on the left or on the right. That rises on the right and it falls on the left. This rises on the left, rises on the right. This one falls on the left, rises on the right. This one rises on the left, rises on the right. So are we understanding that? And then if we're understanding that, let's go and see if we can answer some questions about some polynomials. First of all, I want to look at what is a polynomial is not. If you look at these functions here, there are polynomials and there is one that is not a polynomial. So first of all, you see this one? So that's x to the 8th, x to the 5th. That's fine, that's a polynomial. This one starts off looking good, but then that radical messes it up. Radical, not a polynomial. We're only dealing with powers of x. Furthermore, we're only dealing with powers of x in the numerator. So x to the 6th in the denominator, not a polynomial. Finally, this little function here. Do you know what that is? It's a horizontal line at -2, right? Is that a polynomial? Yes, it is. It's a power of x. What power of x? X to the 0. So that is a polynomial. Now, having established what is and is not a polynomial, we can say some things about where it's going and what's happening on the left and the right hand. So let's take a look at that. Okay, so here we've got, these are all polynomials. So this type of problem, we're not going to trick you and give you something that's not a polynomial, be a polynomial, and we're going to look at how does it fall and how does it rise on the left and on the right. The best way to do this, I think, is to go ahead and just do a little picture for it. So this is positive x cubed. So what does that mean? That means this. I'll do it over here. That's positive x cubed. Now, there's all sorts of variations that would get the same thing. Like it could look like this, right? It could be a lot more curvy, but this is just a good basic shape for a cubic. Let's go ahead and just continue down here. How about this x to the 6th? All right, now just consider this with me. X squared looks like that. X to the 4th looks like that. X to the 6th, do you get the idea? 1, 2, 3. X to the 6th can look like that. Now, it doesn't have to be that curvy. It doesn't have to have that many changes in direction, but it could. That's the maximum number that it can have. It can always have less, as long as the left hand and right hand behavior works out. For instance, this one here, that could be x to the 6th. I don't have to have all of the total number of possible changes in direction. But for our purposes, when we're just saying like the basic picture, we're going to go to the maximum possible. So we're going to go like that for x to the 6th. All right, this one here, we have to think about it a little bit, right? I have to think, what if I expanded this? What would the degree be? So I would have x, and then here I've got x squared, and then here I've got x. So I'm going to have an x squared, and an x. So what's the degree going to be? X to the 4th, right? And then I also really have to pay attention to this negative 2. Negative 2x to the 4th. So what's that going to do? Have you followed along well enough to say what the basic shape of that could be? Here. It's negative, so it's opening down. 4th degree, so it has a maximum 3 changes in direction. 1, 2, 3. It's always 1 less than the degree, the number of changes in direction. So this is 1, 2, 3, 4, 5 changes in direction for a 6th degree. All right, and then lastly, we're going to say, is it fall or rise? That should be pretty intuitive as far as what the language for that should be, and we looked at that on a previous page. So this falls on the left, rises on the right. And that's this choice here. This rises on the left, rises on the right. Rises left, rises to the left, and rises to the right. That's this choice. And this falls on the left, falls on the right. Falls to the left, and falls to the right. That's this choice. Okay? So you have this general idea of expanding your understanding of really an infinite number of polynomials. I can just keep adding on the exponent, and it keeps adding on the number of changes in the direction. And what's really important is what's happening on the left hand and the right hand. Okay? So that is an introduction to polynomials, getting beyond linear functions and beyond quadratic functions and into higher degrees.